Good evening. Welcome to this new series that the Center for Public Policy has started. We are calling it the Inequality Conversations. This is based on the World Inequality Report that has been put in the public domain by the World Inequality Database. We will have a series of these conversations as we go along. The idea is to sensitize ourselves to the issue of inequality, as well as hopefully try and find some solutions or some policy interventions that could go ahead. So this is the first in the series. I'm extremely thankful that my colleague, Prof. Arpit Shah, has agreed to talk about environmental inequality. We will follow this up with several other conversations, not only which are a part of the World Inequality Report, but also other independent research. So we will run this as a series over several weeks and months.
So thanks, Professor Shriram, for the introduction. So like Professor Shriram said, this is part of the Inequality Conversation series that we're starting here at the Center for Public Policy. I'll talk about environmental inequality as part of this talk. So broadly, I think I'll speak for 35 to 40 minutes and then open up for Q&A. But if there's clarificatory questions, please feel free to post them on chat. I'll take them as they come. So I think the background image that I've used on this title slide here shows environmental air pollution across countries. So the red zones show, locations with higher pollution, and greener is the location with lower air pollution. This is, one form of environmental inequality, which is kind of visually represented in this map. So I think, as you can see, Africa, parts of Asia, including India, are zones of very high air pollution. Europe, North America, much lower in terms of how exposed they are. However, environmental inequalities in general can take many forms. So, before I go into the World Inequality Report, let me just quickly lay the broad ground for what kinds of environmental inequalities can be there. So one is obviously, which the report talks about, and I'll go into detail later, is inequalities in terms of carbon emissions, which is basically how much you contribute to global warming through your consumption, which is how much carbon dioxide your daily or your regular consumption emits. So what's your carbon footprint like? And this can be unequal across nations, within nations, and so on, which I'll talk about in much more detail later. There could be other forms of environmental inequalities as well. So there could be inequalities in access to natural resources. An example here could be, inequality in access to water, for example, as a natural resource. So recently, for example, if I talk briefly about this, in 2014 to 16, for example, Maharashtra had severe droughts, and there were 70 to 80% cuts in water availability for domestic consumption, for agricultural usage other than sugarcane crops. So, for example, if your household received 100 liters of water a day, during the drought, it dropped to 20 to 30 liters. So 70 to 80% cut in how much water you receive. At the same time, beer breweries in Maharashtra, which use water and other resources to make beer, they had only a 10% water cut. I mean, so this is one kind of environmental inequality where usage of beer breweries is preferred over domestic consumption of water. Other forms, the image that I showed on the first slide was inequality in exposure to pollution. Which again, air pollution is one form, but there could be other types of pollution as well. Exposure to pollution can vary across countries, like I showed on that map earlier. But even within countries, so for example, all of us know that Delhi is probably more polluted than Bangalore in terms of air pollution during the winter. But even within Delhi or within Bangalore, there'd be variations in how much different people are exposed to air pollution, and also how much they're able to cope with it. So one would expect that higher income citizens of Delhi might be able to purchase air purifiers and kind of adapt to this higher pollution, while people in the lower income segments may not be able to. Similarly, there could be inequalities in exposure to climate threats, and as we all know, the frequency of extreme events like heat waves, cyclones, droughts, etc., is increasing as global warming happens. And different nations, different groups could be differently exposed to these threats. So, island nations like the Maldives may be much more vulnerable to sea level rise than, let's say, countries in Europe or the USA. There could also be inequalities in terms of how much you contribute to natural degradation. So, for example, certain industries contribute much more to natural degradation, mining sector, for example, as opposed to other sectors. So, environmental inequalities can take a lot of these forms, and there's a vast literature on each of these. So, I can't obviously cover all of this in a single talk, but broadly, I wanted to lay the ground for the broad kind of spectrum of environmental inequalities before going into this report. These inequalities are also correlated with many identities. So, like I mentioned earlier, air pollution varies across countries. So, there could be unique differences in both the exposure to environmental harms and the benefits you receive from the environment, and this could vary across countries. This could vary within countries as well. So, for example, one might expect that richer states in India, where consumption levels are higher, may probably be contributing more to global warming than, let's say, some of the poorer states of India on a per capita basis. Gender is another variable or another kind of identity which kind of determines your exposure to environmental threats. So, research in Gujarat, for example, shows that if you look at rural areas in Gujarat, then so there's research which shows that there's areas in Gujarat which are flood prone. Women in those villages which are flood prone are more vulnerable to floods than men because of cultural reasons. So men usually learn how to swim, women are not taught how to swim because of reason related to, it's considered not appropriate for women to learn swimming, or because of reasons related to modesty and so on. Not knowing how to swim makes them more vulnerable to floods. If we look at the opposite extreme, droughts, again, women are found to be more vulnerable to droughts because the nature of work in the household is gendered, right? So women in general in rural areas are responsible for collecting water for the household. In terms of drought, if let's say the water source near your house dries up, it's the woman who has to travel longer distances to fetch water for regular consumption. Again, this kind of makes them more vulnerable to droughts than men. And this would vary depending on the nature of the climate threat, the kind of socio-cultural environment we have. But in general, gender impacts how vulnerable you are to climate change. Caste race is another kind of axis along which vulnerability varies. So, recent research in the US kind of shows that, for example, African Americans and Hispanics cause less air pollution because they consume, their consumption levels are lower, but they are more exposed to air pollution because they tend to live in polluted parts of cities. So this is a double whammy, right? So they cause less of the problem, but are exposed to more of the problem than as compared to white Americans. And there's similar findings we have on cities in India as well. And if time permits, I'll talk a bit more about this later. About some research being done at IIM Bangalore, which finds caste is correlated with exposure to environmental threats. Income is another kind of variable which determines how exposed you are and how much you can adapt. So, for example, like I talked about air pollution earlier, higher income people may be more able to adapt to air pollution threats. Urban-rural linkages also kind of relate to how exposed you are. So, cities, for example, may have better planning structures, you may have better access to resources which allow you to adapt to environmental threats. But cities also have other vulnerabilities. So COVID-19, though it's not an environmental threat per se, kind of exposed this vulnerability, right? Where if you look at the first wave of COVID, it's the slums who were most impacted. So that's where the disease spread the fastest because of high densities, low standards of living, and so on, low levels of hygiene. And again, these same factors could also impact vulnerability to environmental threats. This brings me to the main subject for today's presentation, which is this World Inequality Report. And chapter 6 of this report, which is what I'll be talking about mostly, looks at inequalities in carbon emissions, which is how much you contribute to global warming. And this report was released by the team at the World Inequality Lab, I think led by Lucas Chancel, Thomas Piketty, Emmanuel Saz, and Gabriel Zubun. The lab itself is hosted at the Paris School of Economics and I think UC Berkeley. And I think what this chapter has done is systematically quantify inequality in carbon emissions at two levels. First is across nations. So, for example, how much do people in the US emit versus how much do people in India emit? And second is international inequalities in carbon emissions along the income spectrum. So how much do rich people emit versus how much do poor people emit across countries? So they don't look at other dimensions, let's say gender or caste and so on. So this report kind of looks at inequality along these two dimensions only. But what it does is systematically link inequality in income and wealth to carbon emissions, and for the almost the entire universe of countries. So they cover almost 95 to 96% of the world population. So this is the first kind of systematic assessment of carbon emission inequality, which itself adds value because it has policy implications, which I'll kind of talk about later. And why are carbon emissions and inequality in carbon emissions important to talk about right now? So first is, I think we'll all know this, we are living through what scientists refer to as the sixth mass extinction of species. And what they mean by this is there's a natural rate at which species in the planet get extinct, right? So species get extinct, new species arrive, and so on. But right now, the rate of species extinction is 100 times the natural average, which kind of makes it a mass extinction event. If you look at, let's say, other kind of metrics, so plastic in oceans has increased 200x since 1962 in the last 60 years. Again, our oceans have a finite capacity to absorb, all the waste we produce. So, this kind of leads to, impacts on marine life, contributes to global warming and so on, increase in the temperature of the seas. And finally, atmospheric CO2 concentration is at its highest ever level in recorded history. And if you look at, emissions specifically, carbon emissions, for example, so if you look at, this kind of report does this. So broadly, all the tables and figures I'm presenting from now on are from this report. So I'll kind of discuss the findings of this report and how they, what implications they have for policy making. So if we kind of look at global carbon emissions, in 1850 the world emitted 1 billion ton of CO2 per year. By 2019, this has gone to 50 billion tons. So it's 50x increase. And a lot of this is obviously driven by the increase in the world population, but it's also driven by increase in how much each person is emitting. So per capita emissions in the column on the right, they've also increased 8 times. So while total emissions increased 50 times, per capita emissions have also increased 8 times. And this is primarily driven by lifestyle changes, how we consume energy and so on. This also makes this increase in emissions also makes it important to kind of think about inequalities in emissions at this point in time. And this is the kind of third main reason why we need to talk about this right now. So between 1850 and 2020, in the last 170 years, the world has emitted close to 2,500 billion tons of CO2, of which again you can kind of see the inequality in the bar on the left, where North America and Europe are responsible for 27 plus 22, so almost 50% of global historical emissions. India would fall within the Southeast Asia bracket, but if I kind of take out India separately from this, India has contributed around 4% of all historical emissions. What this effectively means is that if we are to live, or if we are to keep temperature or global warming below 1.5 degrees Celsius, which is what the Paris Agreement and COP26 in Glasgow last year also talked about, the remaining budget of CO2 that we can emit is only 300 billion tons globally. Now consider the fact, what I showed in the last slide, that we are currently emitting 50 billion tons a year. This effectively means that our remaining, if we continue emitting at the same rate, we'll run out of the budget that we have in the next 6 years itself. If we are to, kind of limit global warming to 2 degrees Celsius, which kind of gives us a higher budget, we have 900 billion tons remaining. And again, at the current rate, we'll run out of this as well in the next 18 years. So it's kind of the numbers are a bit pessimistic in terms of our likelihood of remaining. Definitely, I mean, it looks very difficult to remain below 1.5 degrees Celsius, which kind of brings me to the main findings of this report, which is emissions inequality. So, like I said, this report quantifies them at 2 levels: between nations and across nations, and within nations along the income dimension. Right? So, I'll talk firstly about the emissions inequality between nations. This kind of graph shows you historically how emissions have grown for different regions. So if we kind of So I think 2 or 3 main points from this graph. If you look at how emissions have grown, almost half of global emissions historically have occurred in the last 30 years. So if you look at the entire emissions that have occurred since 1850, half of them have occurred after 1990, which is because emissions are growing so rapid. And obviously North America, Europe, dominate the top, the blue and the kind of green portions of the chart. They kind of dominate global emissions. But if you look at recent, after 2010, China and India have also kind of caught up. India is in the yellow part, which is South and Southeast Asia. So China currently contributes to 24% of global emissions. If you look at just the 2019 numbers, India has also increased its share. But North America and Europe continue to remain important. They've been historically large emitters. They continue to remain large. So these were total emissions at the region or the country level. If you look at per capita emissions, which is kind of better way to look at inequality, or a stronger word for that would be injustice in some sense. So the average person in the world emits 6.6 tons of CO2 per year, which is the bar on the left. North America is almost 3 or 4 times that average at 20.8 tons per year, which is the extreme right. South and Southeast Asia, which is India, is in the yellow, which is around 2.6 tons per year. India specifically, again, if I look at India specifically, India is at 2.2 tons per year. It's not shown on this graph here. But what's kind of depressing to note is to stay below 1.5 degrees Celsius, which is the second bar from the left, we need to be at 1.1 tons per year. So the global average is 6 times what we need to be to stay below 1.1 degrees Celsius. 1.5 degrees Celsius temperature rise. No region in the world is below that level right now, including Sub-Saharan Africa and Southeast Asia, South and Southeast Asia, which are the lowest emitters. These two regions at least are below the 2 degrees Celsius mark. All other regions, starting from Latin America till North America, are emitting more than what is required for us to stay even below 2 degrees Celsius. This again is a second kind of way you can look at inequality. Third way to look at inequality would be, compare this to population. So, China emitting 24% of the world's emissions is one thing, but it's important to look at it in the context of China's population as well, right? So China also has the largest population in the world. So, for example, if I look at the rightmost 3 bars, which is where India would be, South and Southeast Asia, our population is shown in the yellow, right? The percentage of population. And the historical and current emissions are shown in red and green. So compared to our population, India and South and Southeast Asia are emitting much lower than their share of population. Europe and North America, both historically and right now, are emitting more than their share of population. China is the interesting one, the leftmost, where historical emissions have been lower than population, but currently they are emitting more than their population share because the way the economy is grown. And also the Chinese economy has largely grown on a manufacturing base, which also is emission intensive. And finally, this is also important to talk about. So all the data that I've presented so far in these graphs, for example, they've looked at the emissions based on the final consumption in the country. So for example, North America's emissions here include North American production and everything that North America imports, let's say from China, or net imports from other parts of the world. There's a second way to look at emissions, which is the second column here, which is the territorial emissions, which is what is produced in the country. And this could be produced in the country also for export. So North America, the bottommost row, their consumption is 20.8 tons of CO2 per year per person. But of that, only 19.8 is produced in North America. The remaining they import from other parts of the world. Europe also imports, is a net importer of goods and services from other part of the world, which is why their footprint or their consumption is more than their territorial emissions, which is what is produced in Europe. All other parts of the world are negative, in the sense that India, for example, produces more carbon emissions than what people in India consume. So, which is basically that we are producing goods and services for the rest of the world and exporting it. Why is territorial emissions important to look at? This is because all the global agreements and negotiations that nations enter into, such as COP26 or the Paris Agreement, they are based on territorial emissions. which kind of makes this interesting, right? Because it's possible for places or rich countries in North America and Europe to kind of export their consumption to other parts. So kind of export manufacturing to other parts of the world. This would reduce their territorial emissions, allow them to fulfill their climate agreements targets while not reducing their consumption. So without addressing climate change, it's possible for you to kind of meet your climate agreement targets. So one kind of policy implication that directly derives from this is we probably need to also measure the footprint of a country, not just the territorial emissions in the country. There's obviously complications associated with this because if let's say in India produces for North America, we are getting money for it, right? So it's not that we are producing this for free, right? So but footprint is also important to consider as well as territorial emissions. Right now, global agreements only take into account territorial emissions in a country, which kind of brings me to the second dimension along which we can look at inequality here in terms of carbon emissions, which is linked to income levels. So globally, how do higher income people emit or consume versus lower income people? This graph kind of shows at the global level a summary statistic of global carbon inequality by income group. So again, the full population kind of emits 6.6 tons. What's interesting here is the bottom 50% versus the top 1%. So the top 1% of emitters emit 110 tons of CO2 per year, which is almost 15 to 16 times the global average. The bottom 50% is at 1.6 tons of CO2 per year. If you kind of again, not very optimistic statistics at both ends, right? So even if you look at the bottom 50%, their emissions are more than 1.1 tons per year, which is what we require to be at 1.5 degrees Celsius. And consider the fact that bottom 50% will probably start emitting more as development happens, right? A lot of the bottom 50% will be in places like Africa and India and in energy scarce conditions, right? So India, for example, has a lot of energy poverty, which is where the bottom 50% would lie. So as people get access to electricity and so on, you would expect consumption to increase. So how do we allow the bottom 50% to develop, to give them space to increase their consumption while reducing emissions of the top 1%? That becomes the important policy question here. This kind of shows the overall share of the group, right? This is simply a multiplying the average per capita emissions of each group into the population of the group. So the bottom 50% consumes only or emits just 12% of global CO2. Top 1% emits 70%. This is very stark kind of measure of inequality, and this is very if you look at the global wealth and income inequality numbers, these are very similar. So carbon emissions kind of follows the wealth and income inequality numbers, and I'll kind of talk a bit more about this as well later. This kind of splits up this same inequality by different regions. Kind of the same story across regions, right? The top 10% emit much more than the bottom 50%. Especially if you look at North America, top 10% are emitting 73 tons per year. India, for example, South and Southeast Asia, India, which would be part of that, emit almost 11 tons. So again, North America, Europe, East Asia is basically Japan and North Korea or South Korea. Again, these are the very high emitters in North America. Again, stand out as an exception, primarily because of the US and Canada. Their emission levels are extremely high in those countries. This is the same graph continued, showing the other 4 regions in the world, including, so again, Russia, Middle East are very high emitters. Sub-Saharan Africa, as you would expect, is the lowest. If you look at 2019 per capita emission. This table shows the same figures at the graph, but I can kind of also splits up. I wanted to highlight just the bottom 2 rows here because they also split up the same kind of numbers for the top 0.1 and top 0.01% of income and income level groups and emission group. Right? So the top 0.1% emit almost 467 tons per year, which is 80 times the global average. And top 0.01% is absolutely extreme, right? 2,500 tons per year, which is I mean massive emission, right? So this is almost 400 times the global average. So if you think about it, the top 0.01%, if you look at the bottom 50%, for example, 1.6 tons per year, and take an average lifespan of 70 years, the bottom 50% are going to emit 100 tons across their entire lifetime. The top 0.01% is emitting 25 times that just in 1 year, right? So I mean, this is extreme. So I think one way to think of this is, extreme wealth inequality is also leading to extreme carbon inequality in terms of how much people are contributing to, global warming. This kind of shows how this inequality has evolved over time. So I think what they've referred to as the carbon elephant curve. So if you look at this curve from left to right, it kind of shows the head of an elephant, and on the right, an upraised kind of trunk. Right? And what this shows is how much emissions have grown in the last 30 years between 1990 and 2019. So as on the y-axis, you have growth in emissions, red line being 0. On the x-axis, as you move from left to right, you move from the lower to the higher emitter groups. So bottom 50% emissions are growing at around 25 to 30%. And they are responsible for 16% of all global emissions growth. So if global emissions have grown, let's say, by 100 tons at this time, the bottom 50% are responsible for 16 tons of that growth. What's interesting is the 70th to the 90th kind of percentile, where emissions have actually declined in this time period. This is primarily driven by climate-friendly policies in parts of Europe and North America, where people have invested in renewable energy, in more sustainable mobility options, electric vehicles, and so on. This has kind of led to the middle class emissions in these countries declining between 1990 and 2019, which is kind of interesting to note. But it's also important to note that if you go beyond the 99th percentile, emissions again rise, and they rise rapidly. So the top 1% is responsible for 21% of all emissions growth. So at the extreme level, which is top 0.01%, you can see that emissions are rising at an extreme level. Again, this table kind of shows the same numbers. For the top 0.01%, emissions they were already emitting 1,400 tons per capita in 1990. It's gone to 2,500 tons now, and their increase in emissions is much higher than even the bottom 50%. And the bottom 50% is where you would ideally want increases to happen, because these people need to come into the development net. And finally, I'll kind of cover this very quickly. If you look at the share of total emissions for the top 1 and bottom 50%, bottom 50%, the share of emissions is increasing, which is desirable. But what is not desirable is the same share is also increasing for the top 1%, which is kind of contributing more and more to inequality. So inequality in some sense has increased this time period. And this is, I think, an important chart to kind of talk about. What's important here to note is, so while when we look at how global environmental negotiations happen at COP26 or any of these environmental meetings, broadly, what's important and what is discussed is how much do developed countries need to contribute in terms of paying for future carbon mitigation and so on. And there's a lot of talk about transfer of technology and funds from developed to developing countries to help developing countries kind of move towards development without increasing emissions. So how do they stay green while continuing to develop? But what this chart kind of tells you is, between country inequality is important, obviously, to talk about. But if we look at how emissions have evolved over time, within country inequality is much more important to talk about or is as important to talk about as within country inequality. Right? So in fact, in 2019, 63% of, so basically what they've done is split up total inequality into within and between country components. Right? So within country inequality, which is high income versus low income inequality in emissions within a country, contributes to 63% of carbon emission inequality, as compared to across country inequality, which contributes to the remaining 37%. Which kind of makes it important to, while it's important to say that US needs to pay India to develop while not emitting so much, it's also important to consider that we need to ensure that high income people, whether it be in US or India, we need to ensure that their emissions come down, while emissions should be allowed to increase for the bottom 50%, because that's a development imperative. If I look at this number specific to India, the full population in India, like I was saying, is 2.2 tons per year, which is 1/3 of the global average. But the top 10% in India consume close to 9 tons or emit 9 tons of CO2 per year. And if I look at top 1 and top 0.1%, it will be even higher. I'll skip this one. Okay, so I think what does this tell us in terms of policy implications? So this is a kind of complicated or kind of dense slide, but I'll quickly try and give the summary insight. So I think the main kind of insight that one can derive from this is policies need to consider inequality in emissions and not just total emissions in a country, for example. So I think what main insight which comes out from this report and what's recommended here, and I kind of agree with this, is the top 10 or top 1% of emitters need to pay for allowing the bottom 50% to develop sustainably. And how can this be done, right? So what's proposed in the report is wealth or corporate taxes for the top 1%. And a wealth tax is obviously stronger than an income tax because it also kind of taxes your investments and your holdings and so on. And the collections from these taxes should be used to finance sustainable investments for the bottom 50%. And what's interesting and also proposed in this report is top 1%, not just a wealth tax, because reason why they're saying wealth tax is because wealth is strongly correlated with carbon emissions. So globally studies, and I think this study also finds, is that if your wealth increases by, let's say, 100%, on average carbon emissions seem to increase by 70 to 80%. So it's almost perfect linear relation, right? Which kind of means that we need to tax the wealthy because they are the ones who are emitting the most, and use that funding to pay for the bottom. What this report kind of also interestingly recommends in terms of a tax is also have a separate extra tax on top of the wealth tax for fossil fuel investments. And obviously this is an interesting finding. I mean, I don't know whether a wealth tax or a fossil fuel investment tax is politically feasible right now, but this is an important idea which needs to be discussed at this point in time. And obviously remove fossil fuel subsidies. So a lot of countries subsidize fossil fuel energy generation, which kind of needs to be removed because firstly, this leads to higher global warming. Secondly, these subsidies benefit mostly the rich at the expense of the poor. And finally, have taxes on luxury investments such as SUVs or air tickets, which will kind of disincentivize such forms of travel, number one, and also ensure that the externalities produced by these purchases like SUVs or air tickets are fairly taxed because of the impacts they have on the environment. On the other hand, for the bottom 50%, what we can think of is public investments to kind of help this group develop, because economic development is also required here, but to help them develop sustainably and not the way in which countries like the Europe and North America have developed. Because if India and China kind of follow that same development path, which has been carbon intensive, then there's no hope of limiting global warming to 1.5 or even 2 degrees Celsius. So I think if we split up climate policies along these 3 dimensions, which is energy supply, access, and end users, which is building, energy, and transport, what's broadly recommended is invest in renewable energy generation, public investments, also public investments on the demand side, which is clean cook stoves or creation of social housing. Again, using low carbon kind of construction techniques, and finally at the end use level, so low carbon transport options using public investments, or investments in housing, energy generation, and so on, or even cash transfers to kind of compensate for taxes on or removal. So removal of obviously fossil fuel subsidies may lead to higher costs of certain goods and services, even for the bottom 50%. So cash transfers to compensate. And for the middle 40%, what is recommended is a mix of the two. Right? So kind of public investments to help them move towards more sustainable development while also taxing their luxury consumption, such as middle 40% also do air travel or travel in or purchase SUVs and so on. So kind of tax that while subsidizing the greener options like electric vehicles. So parts of this, a lot of countries are already doing that. But I doubt anybody is doing all of this at the same time, especially the wealth and corporate tax, or wealth taxes are not a reality. And corporate taxes, in fact, seem to be declining in most countries as opposed to increasing. I think the report also kind of projects possible revenues from a wealth tax. So I'll just highlight one number here, which is the wealth tax revenues from this entire group. So I think they propose, wealth tax percentages from 1 to 4%, depending on how much income or wealth you have. This could generate potentially $1,695 billion, which is 1.6 trillion. To put this in perspective, India is demanding, $1 trillion from the developed world to fulfill the climate commitments that we have made under the COP26 in Glasgow. So it's not a huge number. This 1.6 trillion will not be sufficient to fund everything, but it's a major number nonetheless. So broadly, okay, to quickly summarize the policy implication here, what we need to do is, kind of track individual carbon emissions. Firstly, start tracking individual carbon emissions within the country level, including estimates of inequality, which is not being done in most countries, I think including India right now. What we do track is total carbon emissions, which is then used for global negotiations, but we're not tracking inequality in carbon emissions. And then factor that inequality into emission reduction policies. So, this kind of policy grid that I showed, obviously this is a summary kind of grid for the whole world. I mean, this will need to be context dependent for, if we are to think of this for India, this will need to be context dependent and so on. But this kind of broad message is, we need to tax the higher emitters to pay for sustainable development for the bottom 50%. So I think this is what I wanted to cover kind of right now. I think I'll open up for questions at this point. Yeah. Is the screen still visible? Okay, I think the sharing is stopped. So Sriram, you're on mute.
So thanks a lot, Arpit. I don't think we have any questions that have popped up yet. So let me start with my own set of questions.
Yeah.
One is wealth tax a solution, or high income tax a solution for environmental problems? It's a solution to inequality in one sense, but environmental inequality is taxation a sharp instrument to arrive at some sort of an environmental. That's point number one. The second question I wanted to ask was, are we only looking at emissions as an environmental problem, or is it also possible for us to look at where is the source, which is extraction? And is there something that one could do vis-a-vis extraction? These are the two questions I have.
Okay. So I think the first one is a wealth tax a good option, or let's say, I think you said precise enough option for environmental inequality. So I think broadly what's interesting is, so obviously wealth tax would be an option for income inequality because it's a direct kind of counter to income inequality if you tax the top 1%. But from an environmental perspective, that answer is not so obvious. But I think interestingly, what multiple studies across the world have found is that wealth and income are almost very strongly correlated with carbon emissions. So in some sense, 100% increase in income leads to a 80% increase in carbon emissions. So this is almost as good as 1:1 relation, right? Which kind of makes wealth or income a very good proxy for carbon emissions, which also kind of tells you that while it's not a 100% precise instrument, it's reasonably precise in terms of, because it's very strongly predictive of how much you are emitting. But this is only in terms of carbon emissions, right? There's like I think mentioned at the start of the talk, there are other forms of environmental inequality as well. So, for example, this could be inequality in air pollution or inequality in how much access you have to natural resources, and these could be driven by not just income but also social identity, gender, caste, and so on. Now, let's say one of the gender inequalities I talked about was how much women have to travel to fetch water in case of a drought. Now, a wealth kind of tax would not be a solution to this kind of inequality, or I don't see a wealth tax being a solution to how exposed you are to air pollution. So I think let me try and present one more slide. This is based on research we are doing here right now at IIM Bangalore. Is my screen visible?
Yes, it is visible.
Okay. So yeah. So I think this is research we're doing here right now at IIM Bangalore. The graph here shows on the x-axis you have temperature, right? So increases as you move towards the right. And this is a histogram. So on the y-axis you have the density, or kind of the histogram density. We are showing here 4 groups of kind of people. So based on religion and caste, what you see is the green kind of curve, which represents the Muslim population, and the red, which is SC/STs. These are the we would say kind of marginalized groups. And this is just for Bangalore, right? They are exposed to higher levels of temperature in summer, as compared to others, which is the traditionally higher castes and OBCs, which are the purple and the blue curves. Now, this happens because residences in Bangalore are segregated. So, different groups live in different parts of the city, and hence they are exposed to different levels of environmental goods and bads. So broadly, what we are finding is higher income, higher caste groups, and also religion should be mentioned. They live closer to green spaces, are exposed to lower temperatures. They are also exposed to lower air pollution. Sorry. Yeah, which kind of now I don't see how a wealth tax solves for this, right? Because this is systematic inequality driven by other factors. But in terms of carbon emissions per se, I think the wealth tax is precise enough based on the research that we have so far. I think, Professor, can you repeat your second question?
See, the question is, can we do something about extraction? Because we are only looking at emissions. That was what I was asking.
Can you specify extraction?
I mean, where is the source of all this problem? Is it fossil fuel, etc., etc.? And therefore, is there a way of taxing the source itself, or making the source a little more sustainable in the sense of replenishment, rather than, because when we look at any of these issues, it is all viable essentially because it only looks at the cost of extraction, not the cost of replenishment. The moment we talk about the cost of replenishment, it becomes unviable. So, is there a way in which we can look at it?
So obviously, I mean, I think your point is correct in the sense that, so I think the way these emissions are measured, they do kind of look at where the extraction is happening and how much. So territorial emissions would kind of take into account. I mean, so what the emissions factor in is your energy consumption broadly. So if your electricity is powered by coal, you will emit more as compared to renewables, but they are kind of not looking at, as you correctly said, cost of replenishment. And obviously, this is a tax is an economic instrument per se. So beyond the point, I mean, if let's say market prices are good enough that even with such a tax, you will continue to extract so much, then a tax will not solve for the problem, right? Of kind of limiting emissions to the desired level. And such taxes, I mean, to precisely calculate a wealth tax, which would limit emissions such that we don't exceed 1.5 degrees Celsius, that's very tough to do. There are other kind of regulatory instruments you have in place, which is more the command and control kind of style, where you can simply ban extraction beyond a point, beyond the natural rate of replenishment, which is kind of easier to calculate. I think, does that answer your question?
Well, sort of. See, the other thing is we constantly, electricity and other forms of, fuel. But what is the net impact? I mean, even electricity generation is highly polluting in that sense, isn't it? So are we only, I mean, when you look at just the emissions part of it, are we looking at one part of the problem and not looking at the entire problem in, holistically? That's one. Second is, I think, Arpit, there's also a question on the chat. So you could.
Yeah, I think. So I think, the broadly when they calculate emissions, this would look at all sectors of the economy, including energy generation. Right? Energy generation would obviously be a dominant part of this, but they'd look at other forms of consumption as well. So this is not the calculation of emissions would, so for example, also include land use change. So if you let's say cut down a forest for a certain project, the number of trees cut down would also count as part of your emissions, right? Or consumption of meat, or emissions from agriculture and so on. All of these are accounted as part of these emissions. So it's not just power generation. So the methane emissions from cattle and so on are part of this calculation, and they're part of how final emissions for final consumption are calculated. Looking at, so Professor Raj Lakshmi has a question on that. So the unit of analysis for emissions are corporations, but for wealth taxes it is individual. So I think what they're recommending here is wealth tax as a mix of corporate and individual tax. So firstly, I think the emissions have been calculated here at the level of so what they've done is allocate emissions to the household and the corporate separately in this analysis. So the total emissions for India, for example, would include separate estimates for household emissions in India, which is what people directly consume in their households, which is primarily electricity consumption, and other forms of consumption, let's say transport and so on, and corporate kind of emissions separately. This would come under other broader economic activity. So what they're recommending is a mix of two types of taxes, which is wealth taxes on individuals, because like I was saying, wealth is strongly correlated with emissions, and corporate taxes for corporate profits. So I think both are taken into account as part of this total analysis. And corporate taxes, unfortunately, as we all know, are broadly declining across the world, including in most parts of the world. Does that answer your question? No? Okay, I'll kind of move on. So I think there's a couple of other questions from Hari Natarajan on the chat. The first one is, can the bottom 50% really be allowed to increase their emissions, given that some of them have a per capita emission higher than the allowed 1.1? So I think, Hari, you are correct that we need to be at 1.1 to kind of limit global warming to 1.5 degrees Celsius. Even the bottom 50% in most countries are above this. Now, can we really allow them to increase emissions? So I think what's being recommended here is not allow them to increase emissions too much. So I mean, so as they get access to electricity and so on, and no, a large part of this bottom 50% is are suffering from what is commonly known in the literature as energy poverty, right? So they absolutely have no access to electricity, or even if they have it, it's for very few hours a day and so on, which kind of impacts your ability to have a decent education or healthcare and so on, because all of this is, hospital in our area needs to have electricity to treat you well. So if you're in an energy scarce or energy poverty kind of situation, a lot of other factors get involved. So one would expect that just for development to happen for this segment of the population, their broader consumption, or at least their electricity consumption, has to increase. This would lead to, I think, some rise in emissions, but not at the level at which Europe and North America have experienced, as their lower income segments have grown in the last 50-60 years. But what we need to do is allow this group to get access to energy and kind of enter the development net, but while not increasing emissions too much through sustainable energy options. So what's recommended here is this kind of wealth tax from the rich to kind of fund renewable energy investments for the poor, which kind of gives them access to electricity, but without allowing emissions to increase too much.
So,
Yeah.
I think I have an additional question. See, your taxation solution, Arpit, is within a sovereign, right? It is not across sovereigns. And within a sovereign, I mean,
yeah, within a sovereign. Yeah.
But
this is obviously a global thing.
Yeah, whatever we can do is between the rich and the poor in a given
country
boundary where the sovereigns writ.
Yeah.
Our inequality is between first world and third world. How does one sort that out without the instrument available for taxation? If we were to, I mean, all these are voluntary commitments saying that we'll be net carbon zero in 2075 or whatever it is.
Yeah.
That's where the dichotomy comes, right? I mean, because we also need to sort of economically develop and at the same time need to be quote unquote sustainable. And the solution that we have is to tax our own rich and sort of make it better. So is there a problem there?
So I think or at least I think the remote is kind of limited in this because it only looks at taxes within a country. But my perspective on this would be, so I think firstly, I think what the report kind of tells us is 2/3 of inequality is within country, which a wealth tax can kind of address because it's also within the sovereign. But now, whether a wealth tax is politically feasible and whether anybody will ever kind of implement is a separate question. But if we take a normative stance, then that is where one would kind of recommend a wealth tax to penalize the emissions of the rich. What additionally we need to do, and of course, I think you are correct that there is obviously inequality across countries which a wealth tax cannot address. I mean, India can't tax the wealthy in the US. But what I think we are not, what we kind of also need to think about is what India is demanding from, let's say India has made 5 commitments in COP26, which include things like 500 gigawatts of renewable power by 2030, and we'll reduce emissions by 20% by 2030, and so on. Now, all of these for which India is saying, we need $1 trillion from the developed world. So the international kind of climate negotiation and those agreements should be addressing inter-nation inequality, which is how much should be paying developing countries to kind of allow them to move towards sustainable development. While the inequality within countries is what we need to address through a wealth tax. So there's combination of two. Now, unfortunately, what has happened is that even in the previous, the Paris Agreement and so on, the developed countries kind of said we would give $100 billion to the developing world and technology transfer to kind of help them invest in renewable energy and sustainable mobility, sustainable energy transport options. That money has not materialized. So while these countries have made commitments, the money has not come in as of yet. Now, obviously, we have no way to enforce that this money comes in, right? Because these are different sovereigns, or you don't have policy making power over another sovereign. So whether these agreements work in practice is obviously another question, because the money should have come in has not come in, and now India is in fact demanding much more. So whether that money will also come in is a moot question, and if it does not, then will India fulfill its climate commitments, or will it be justified to not fulfill? So these are all difficult questions for which, as of right now, I think we don't have the answers. But I think broadly that's the perspective. So okay, let me look at Hari's. You had another question?
Yeah, I mean, I just wanted to check, what do you think of Bhutan and its gross national happiness and the commitment that they've made to themselves that the forest cover will not go beyond a certain this thing, and they're pacing their sort of growth according to this thing, and where we have a paradox of it's a happy country, happy but poor country, or happy but underdeveloped country. So how do you look at it?
I mean, if there were a way to kind of do that while ensuring, so I mean, if we were to say, the villagers in India are happy and kind of use that as excuse to not give them energy access, that would, I don't think that's the kind of argument I would make. We need to give them, access to modern energy and so on. Happiness can be, I mean, I need to study Bhutan in much more detail to kind of give a better answer. But, things like forest cover, for example, like you said, they've said they won't let forest cover reduce below a certain level. And I think that's the right kind of step to take, right? I mean, beyond the point, you can't let your environmental resources degrade, even for development, right? Because beyond the point, I mean, the world does face an existential crisis. So, I mean, you keep cutting your forests. I mean, beyond the point, there'll be no world left, right, to develop. India is strangely following a very different. I mean, India's forest cover is a very separate or different story. India has regularly shown increase in forest cover in the last 15-20 years, but recently, people have started to look at the details of this number, and they found that large part of this increase is because India has now started to count different kinds of things as forests. So earlier, forest meant a certain thing. Now, even coffee plantations get counted in the. So India releases what is an annual, state of forest report, which counts, how much forests are there in different states and so on. What the report, if you look at the nuances of the report and find out what we're counting as forests, even coffee plantations or a few isolated trees in a city are now counted as forest in that report. If you count all of that as forest, then your forest cover is likely to increase. So what we are ending up doing is cutting down our actual, old growth kind of actual forests, replacing them with a lot of monoculture plantations, counting them as forests, counting coffee plantations as forests. Now, statistically, there's various ways to show that we are meeting our development kind of obligations, but when we're actually not, and this is just one example. So, whether we can follow Bhutan's example is a different question. I mean, I don't have a clear answer to that. But my view is that bottom 50% we need to allow them to develop and give them space to develop, because the top 10% already have, right? So it would be unfair of us to say that the bottom 50% should not have access to modern resources, and the top 10% should not pay for what they have already or are continuing to emit. Okay, so I'll take Hari's second question, which is, should our policy focus be more on adaptation, given that it looks unlikely we limit temperature rise to 1.5 or 2 degrees Celsius? So, I mean, our policy focus. So to answer that, I think our policy focus needs to be both mitigation and adaptation, and they should not be exclusive of each other, right? So it's not as if we need to do only carbon mitigation and not look at adaptation options. So even if we temperature rises to 1.5 degrees Celsius, there's ways to kind of, there are scientific models which kind of show that these regions are likely to face these kinds of threats. For example, coastal areas will face more cyclones, or regions in certain states may face more floods. Some places may face more heat waves and droughts. And there are scientific models which kind of allow us to predict those things, or kind of estimate, what the increase in frequency of these events is likely to be, even for any kind of temperature change. So we do need to focus on adaptation measures, but these need to be, tailored locally. So there's no, common adaptation measure which kind of works across the country. So we need to tailor adaptation measures to different locations depending on what the climate models are telling you regarding the likely climate threats for that location. And mitigation needs to be done separately, which is what this wealth tax and kind of talking about. So I agree with you that it's unlikely we'll limit temperature rise to 1.5 or even 2, but I don't think that does mean that we should not try, right? I mean, we need to kind of try to tackle the problem on both sides. There's a few other questions from Sunil Vinayak. Sunil is asking, can you really tax the wealthy who employ world-class lawyers to stash their money in tax havens? So obviously, I mean, like I'm saying, this is a normative kind of analysis where we are saying the wealthy should be taxed. I am kind of pessimistic about whether our ability to tax the wealthy really exists. And you are correct. I mean, especially because if all countries don't agree to a tax at the same time, you will just have people moving their income and assets and kind of opening shell companies in all kinds of countries, which is kind of what happens right now. Question 2 is, as we speak, what is the average rate of tax by the wealthy versus the ordinary wage earners? And I often read that the wealthy often pay lower taxes than the less wealthy. I mean, so in most countries, taxes would be progressive. In the sense that, as your income slab increases, you'll start to pay higher taxes. So India, of course, the highest slab As you, I think, move beyond a certain lack of income, your slab keeps on increasing. But if we account for, I think, all exemptions, then I think my colleagues are maybe better placed to answer this. But if we account for all the exemptions we are allowed in terms of PPF and all of that, the wealthiest income earners in India are probably paying 23-24% income tax, if I'm not completely mistaken. Lower wage earners are paying less than this, but obviously this needs to be more. I think right now the difference in tax, or the percentage tax difference between wealthy and rich, is lower than the difference in their carbon emissions. And in the kind of, there's an option to tax the wealthy more. Wealth tax obviously is much more stronger than an income tax. There's one more question from Lokesh. So I've read that Cuba is the most sustainably developed country in the world. Has it to do with the form of government there, or has the promulgation of capitalism, which promotes more consumption, as the way to go? Is this responsible for the huge rise that we see, especially in the last 3-4 decades? So Cuba specifically, I don't think I know enough about Cuba's development to kind of answer whether sustainable development in Cuba has to do with the form of government there. So obviously they don't follow the capitalistic model. I mean, they've had a different form of government for decades now. But I don't know enough about their development to kind of answer that. But to your second question, which is has capitalism kind of promoted more consumption as the way to grow? I'd say it's not capitalism by itself, right? It's kind of unregulated capitalism, where we've allowed companies to chase profits, and companies to chase profits and wealth without penalizing them for the externalities they impose on the environment. So regulated capitalism, where you kind of tax them, either tax is economic instrument, but either tax them or other forms of like I said, command and control kind of techniques, right? Where you simply say that beyond a certain level you can't extract so much natural resources because this is a natural rate of replenishment in nature. So those kind of regulations need to kind of allow for capitalism while preventing its excesses, right? Because capitalism itself, some would argue, it has led to a lot of innovations, a lot of development, and a lot of increase in quality of life. But obviously it has also done so at the expense of the environment, and which is kind of the biggest externality we face right now, right, in terms of existential threats. So I think that's. I think there's no more questions on chat. If there's any other question, I can.
No, I don't think we have any other questions, Arpit. Would you like to have some final word before we close?
So I think thanks. I think Center for Public Policy for this opportunity to present. So I think the findings of this report, and I think this is a very important and interesting report because of the implications it has. So while a wealth tax is feasible or not, I think the most important thing this report kind of does is bring this on the discussion table, or at least whether we are ever able to implement a wealth tax or not, and whether it's the right instrument, it does need to be discussed as a possible instrument in terms of all of the other options that we are considering in terms of limiting climate change. And secondly, just a very stark quantification of the inequality of climate change is important, because it kind of points to a policy needing to be tailored and to account for these inequalities without just kind of using a uniform approach, either at the country or between country level.
Thank you very much, Arpit, for sparing your time going through the report and educating us on this matter. I guess these are very, very complicated conversations, and we need to continue to have these. I don't think we have a easy solution, but there's the only way that we can move towards a solution or a policy intervention is to keep talking about it, discussing it, get ideas from all over the place. Thank you very much. Thanks a lot for all the viewers for having joined today's conversations. We'll have one more talk on taxation by Professor N.S. Viswanathan, former Deputy Governor of Reserve Bank of India, next week, next Monday, around the same time at 7 o'clock. Hope to see you all there, and we will continue to have this series of conversations as we go along. Thank you very much. And
Thanks everyone for the question. Thanks.